Hey there, welcome to the video. Today we're tackling a tricky problem involving a massive UInt64 value stored in a string. The challenge lies in preserving all 64 bits of this value without losing any information, which PHP struggles with due to its lack of native UInt64 support. Now, let's dive into the solution. By leveraging the power of BC Math, we can split the UInt64 number into two UInt32 parts, a high part and a low part. This separation ensures that no bits are lost during the process. The code snippet provided neatly demonstrates how to achieve this split and pack the two parts as signed 32-bit integers in big Indian format. That way, we can maintain the integrity of the original value without any precision loss. Pretty neat, right? Building on our previous step, we can now focus on reconstructing the original UInt64 value from the packed 32-bit parts. Using the unpack function, the code snippet efficiently extracts the high and low parts from the packed data. By utilizing BC Math functions like CAD and BuckMul, we can reconstruct the initial UInt64 value by combining these two parts back together. Voila! We successfully restore the original gargantuan UInt64 value from its split components. In summary, we've effectively navigated around PHP's limitations with UInt64 values by strategically splitting and packing the data using BC Math functions. This approach ensures that every single bit of our UInt64 number is accounted for, maintaining its integrity throughout the process. Thanks for tuning in to unravel this coding conundrum with us. Don't forget to subscribe, like the video, and leave a comment below with your thoughts. Remember, coding conundrums are just puzzles waiting to be solved.